In this video, we are going to learn about the basics of CST Studio Software Suite 2020. Here, I am going to show you how to use the software, the tools that are very helpful for designing different projects on this software, and we will be later on working on designing of different types of antennas. Let's begin this tutorial by first clicking this project template. Here, upon clicking this new template button, we are going to see the workflow that we can select from within these options. Here you can see that we have static low frequency, microwave and RF optical, EDA electronics, EMC EMI, and particle dynamics. So first of all, we are going towards this microwave and RF optical. Click on this and you're going to see some further options here. The first one is the antennas, then the circuit and components, radar cross section, biomedical exposure SAR, and optical applications, and finally periodic structures. Here we are going to use the first option, which is the antennas. Mostly we will be working within this domain, but I am also going to give a few demonstrations on how to find the radar cross section of different objects, and we are going to place various CADs or structures within this software so that we can evaluate the RCS of that object, right? But for now, we are going to see uh, how to design some basic structures within this software, and for that we are going to select this antenna option. Click next. Then within this antenna option, you can see there are further some workflows options, uh, which are waveguide. Either you are going to design the waveguides or microstrip patch antennas or slot antennas, the wire antennas, phase array, unit cell, mobile phone integrated reflector, dielectric resonator, RFID. So I will be going through these options in later stages of my video tutorials. For now, we are going with this option, which is the planar patch slot, right? So click on next. Then as you can see, we have three domains. Here you can see that we have the time domain option, frequency domain, and the multi-layer. So most of the time, whenever we are going through this process of setting up the project, so the software automatically suggests you the most useful solvers for your typical application. For now, we are going with the time domain, which says it is recommended for wideband or multi-band antennas, and there are also the other options like the frequency domain and the multi-layer, but I'm going to explain you later how to use these domains and what are the purpose, right? So within the time domain, we are going to see some setup of the units, and most of the time I just keep it as it is, like in the default mode, but you can change these settings as per your requirements, right? So click on next, and here you are going to set the range of frequency within which your project is going to be operable. For now, for example, we are going to set it to from 1 gigahertz to 2 gigahertz, right? And after that, you can see that the monitors are now enabled, and you can either select the monitors right up here, or you can set the monitors after the after this window, and even during the setup of your project, right? So it's not any hard and fast rule to select the monitors right here. So I'm going to keep just the far field monitor here, and within this option you can see that the first value is the minimum value, the last value is the maximum value, and this is the central value. So you can set as many options as you want, right? So right now it is going to show us the far field at 1 gigahertz, 1.5 gigahertz and 2 gigahertz. So let's keep it as it is and click next. And finally you can set the template name here, and right now I'm going to keep it as default. Finally click finish, right? So within 4 to 5 seconds you're going to see that your project is now ready, and you can now start working on your project. First of all, you can see we have the navigation tree on our left side, and we have some menus which are on the top portion of your screen, like the file, home, modeling, simulation, post processing, view. And we are going to go through these options as per our requirement, but right now I am going to tell you few of the options that are quite useful during the design of any project right here. So let's start with the navigation tree. Here you can see that we have the components folder, the group folder, the material folder, and there are faces, curves, WCS, and so on. So the components folder is used for whenever you're going to design any object in this area. For example, I am going to the modeling, and then we are going to select this brick option, and we are going to design a random brick right here. So don't worry, I am going to explain you this the design process. Right now I'm just uh, creating a random model over here. As you can see, I have created a simple cube over here, and upon clicking the OK button we can see the object cube here, and its material is set as PEC, that is the pure electric conductor. And now you can see that we have few other options here, that is the excitation signal. Most of the time we keep it as default, right? And next we have the field monitors, that is which we set just at the beginning of our project setup, right? So this is the far field at 1 gigahertz, 1.5 gigahertz and 2 gigahertz. Next we have the mesh, and we are going to see in later videos how to set the mesh, right? From these options, that is the mesh view and global properties. So for now we are not going to go through these options. All right, so as you can see we have this object right here, and now the component folder is showing us a plus sign, which means that we can now uh, just edit this cube again by double clicking on this solid one, right? You can change the dimensions of this cube again easily, but as you can see that you cannot change the name of that cube or its material from this option. But don't worry, you can just change it by right clicking on that object and either rename it, right? Or by just, if you want to change its material, so right click on it and then go to assign material and color. So from here you can either go to the new material option, or you can go to this load from material library, uh, and within the library there are hundreds of options already available by default by this software developer, and which helps us a lot in selecting material for our objects, right? So anyways, next thing that we want to see is this solver, right? Which is by default is set to uh, time domain solver. But right now you can see that since we don't have any excitation source, that is the there is no port right here, and the port is empty, right? This port folder is empty, so that is why we cannot see the settings of this time domain solver. But don't worry, we are going to go through that option when we are going to design a microstrip patch antenna or wire antennas uh, for our project, and then we are going to assign the port for that antenna, right? So within this home tab, as you can see, we have this units option where you can change the units of your project, but I highly recommend you to select your units carefully at the start of the project, right? Because after or during the project designing, it is not like much recommended to change units. It might just affect the cat of your project, right? So it's highly recommended to carefully select the dimensions of your project at the start of your project, right? So the next thing that we can see here is the start simulation button. It's a quick option to just press this button and the simulation will start immediately, right? But the simulation start button is also available when we are going to say this option of the setup solver, right? We can also see the start simulation button within this setup solver. So after that we have this optimizer tab, and here you can see we can assign different parameters here, and also the minimum maximum value, through which we can automate the optimizer process or the optimization process of any kind of project, so that you can easily just automate your project to bring you some desired results using this optimizer option, right? Also the parameter sweep, this is also kind of manual, but like, or you can say semi automated process where the values of your parameters will change and all the results will be saved, so that you can see at the end of the results that which value give you the desired results, right? So we are going to go through this optimizer tab as well as the parameter sweep during the design of our antennas. All right, so next we have this mesh view, where you can see the meshing of your project. Right now, as you can see, this is a surface, this is kind of a surface mesh, right? Which is known as the hexahedral or the hexahedral meshing. So there are different types of meshing that depends on the solver type which is being selected over here. For example, for time domain solver, we have this hexahedral or the hexahedral TLM mode. But when we are going to go or try the integral equation solver, then this integral equation solver basically selects the surface meshing, and we are going to see how the surface meshing actually is applied on your object, right? So for now, just stay with this time domain solver option. Next we have this history list. This is one of the most important and most useful uh, tab that is going to be used during our project designing, because the history list is actually the list which is being developed during your project designing, and at any stage of your project, if you want to go back to any specific step, so this history list is very helpful, as it can allow you to edit or delete any step that was taken during the project designing, right? All right, so next we have the calculator as well as the open report, but we are going to see those options in our later videos. Now, one of the option that is very quite useful is the macros, and using the macros, we can select or design the impedance matching calculators, and we can easily find the length and width of our microstrip patch that will give us the desired impedance, right? Also the macros option allow us to save the results, the 2D as well as the 3D results, either in as a simple picture or a video, so that you can use them either in your research papers or your presentations, right? So after that we have the modeling option over here. Within this modeling option, we can either import or export 2D or 3D models, right? As you can see within this 3D import files, we can select the CATIA, the STL step file, and I mostly use this CATIA option since we first go through the CAD designing using the CATIA software, right? Also, during the project designing, when our project is completed, so most of the time we export our model to the Jabber file so that it can be fabricated like the antennas, and this Jabber file allow us to fabricate our antenna, right? So we are going to see how to generate those Jabber files and view them later after its generation, right? So also we have the background material library, right? And we have different kind of objects that can be designed like this brick, sphere, cone, torus, cylinder, and so on. So right now, as you saw, we designed this cube using this brick option, but we are going to see the other objects as well in our later videos. Um There are other options like this bend tool, modify locally, and shape tools, where you can actually heal your CAD files, but we will be looking at these steps. These are the kind of advanced options, and I just don't want to confuse you people with these options, right? So in the beginning of the project, these tools might not be just so helpful for your project. Other than this, we have again the history list again within this modeling tab as well. You can either go to this history list from the modeling or the home button. And one of the most important three axis is the local WCS that can be used to cut shapes in cut your objects in different shapes. And we are going to see how to use this local WCS access, right? So for now I'm going to disable it. And next we have the simulation tab. Here we can see we can again set our frequency uh, or added the frequency. Using this frequency range setting, we can set the background that is being applied on our object, and we can set the boundaries, right. By default it is usually open boundary. So the port that we were discussing at the beginning of this video, that is being shown right in this folder, that port is actually designed using these options like the waveguide port, discrete port, plane wave, or the lumped element, right? So for microstrip patch antennas, for example, we usually use these waveguide ports. For antennas like the dipole antennas, we usually set this use this discrete port, right? And for RCS analysis, we usually use this plane wave port, so that we can uh, check the RCS of any object like the ship or the any kind of an aircraft, right? So and the lumped components, that is the resistor, capacitor, inductor, can be designed using this lumped element option. Next we can see this field monitor. At the start of the project you saw that few monitors were available that can be selected for your project, but the actual monitor tab or the option is within this simulation tab. That is, you can select the E field, H field, surface current, which is quite helpful. That this surface current is very useful and very desirable for writing your antenna research papers. This result is quite desirable. And next, the far field, right? Far field of your antennas or the RCS of any object. Next, the field source. This is also being required for during the antenna placement or the RCS checkup of your object, right? The CAD objects, CAD like the ship or the aircraft. And next we have this surface current, TLM mode, the power flow current density, power loss density SAR. So this SAR is quite desirable result, especially in research papers write up, right? So we are going to see how to just present the SAR or analyze the SAR, right, of any antennas that going to be designed using this software. So anyways, after that we have again the setup solver over here. So again we have the optimizer and parameter sweep option over here, the pick option, and this is quite useful, especially when you are going to place the ports on your desired object, right? After that, we have again the mesh view and the global mesh properties over here. So after the next we have the post processing tab, and this tab is usually after the completion of your simulations, like whenever you're going to uh, just you if you need the envelope correlation coefficient, diversity gain, mean effective gain of your antenna designs. So this post processing tab is where it gets helpful, right? So also we again have this import export option over here, and this option is especially useful when we are just checking our S parameters results or the far field results, so that we can export that those results in numeric values, and we can later on use those numeric values to either just reprint them using the some good softwares, right? So we are going to see those options, how to use these options for importing or exporting different kinds of ASCII values that are useful for our results development. All right, so next we get the results template, and this is quite useful for the ECC, DG, MEG graphs. There are quite plenty of results that can be generated using this template based post processing, or that is the template based post processing option. But we are going to mostly just uh, check the ECC DG graphs using this template based post processing option, right? So after that we have the view tab over here, and as you can see, this is quite useful when you are going to uh, just change how your project should be visible right on your screen. For example, if you want to remove this working plane or remove this wireframe boundary box, right? So these all options are visible or editable using this view tab. Also you can change the orientation of your project visibility using this either zoom option, pan option, right? By clicking the zoom, you can zoom your project. By pan you can move that object, right? Rotate is the option that can rotate your the orientation of your project, right? So we are going to see these options during the development of some basic antennas using this software. So if you are new to this software, then this video might be helpful. I hope this is helpful for you, so that you can know the tabs that are available within this software. For now I just I'm going to close this video, right? So and if you are new to this software, so I highly recommend you to just install this software and go through all these options, check out the tabs and the options within these tabs, and as I showed you now, so play with them so that you can see which tab and which options give you which properties, right? So that's all for today, and see you in the other tutorials, and take care, have fun, bye bye.